Hello, everybody. Let's see how long the homework takes. I'm just going to do it. So, practicing some algebra skills. So, 1a is x squared plus px minus 7. And it says complete the square. So, I'm going to ignore the 7. I'll look here. I know that if I want p, this coefficient has to be half p. Because if I expand this, I'll have x squared plus half p plus another half p, but then this is going to produce p squared over 4, so I have to subtract p squared over 4 to compensate, minus 7. So there's the answer. Let's do 1b. We're still completing the square, so 3x squared plus root 2x plus 1. I'll leave the 1 over here. I'll factor the 3 out, as we did in class. So now this is x squared plus root 2 over 3x. And now I can complete the square on this part. I'm going to write my brackets first to be sure that everything I put here is still being multiplied by the 3. So here I'll have x plus half that coefficient, which is going to be root 2 over 6 squared. This is going to produce an extra root 2 over 6 squared, which is the same thing as 2 over 36. So I will subtract the 2 over 36. And then I'll finish it up by multiplying back in. So this gives me 3x plus root 2 over 6 squared. And then if I multiply that back in, I'll have, so 6 divided by 36 is 1/6. And then plus the 1. So I could write this as 5/6. I guess let's just do that. Great. Okay, let's do 1c over here. So I've got 13y squared plus py minus q. Let's factor out the 13. So now I've got 13 times y squared plus p over 13y, and then I'm going to have the q over here still. Let's go ahead and complete the square. So I've got y plus half that coefficient, so half that would be p over 26 squared. This is going to produce p squared over 26 squared, so I will now subtract the p over 26 squared to compensate. I've got the negative q, and let's multiply back in the 13. So now I've got 13 y plus p over 26 squared, and then multiply the 13 back in here. What does this even say? Oh, that's a p. I gotcha. So you can think about this, right, we had 13 times 2 down here. So let me sort of rewrite this whole thing to make it clear how it simplifies. So this was 13 times 2 in the denominator squared, so that's another 13 times 2. And then I'm multiplying the 13 back in, so that gives me a 13 on top. So 2 of the 13s divide, and so now I can rewrite this in the following way. So p squared, and then I'll have 13 times 4 in the bottom. Times q. So my purpose in showing the factors of 26 here was just to show that when the 13 multiplies back in, you don't have to break out your calculator. You can think about what went into this, this 26, and you can do the divisions using tiny numbers easily without the calculator. Okay, let's do 1d. Given the equation blah, so the equation 3x squared plus 4 times y squared plus ky equals -1. Okay, so given that equation, complete the square to write it in a form where the y's are together and the x's are together and so on. Okay, so it's really just asking me to complete the square here. So the 3x squared stays where it is. This is this the same as the problem up here? Yeah, it's the same as the problem up there. I guess let's just do it again though. So y plus k over 2 squared, and then minus k squared over 4. And then but remember the k squared over 4 is part of the constant because k is just a number. So I need to multiply this back in. So 3x squared plus 4 times y plus k over 2 squared. And then 4 here divides 4 there. Or rather, 4 here divides 4 there. So now that's minus k squared. And now we'll add the k squared to this side. Because that's the form that was being requested in the problem. So k squared minus 1, like this. And just to be really clear here, if I request a particular form, such as all the constants be on the right, you have to think in your mind kind of what counts as constants. Constants are any terms that are just variables, that are just numbers that don't involve variables. So like I was saying, the k is a number, so if you were going to plug in whatever value of k is, you would get k squared over 4 is, again, just a number, times the 4 is just a number, so anything that's just a number you'd move over to the right because those are constants. Okay, let's keep going. So 1e says do the same thing, but it gives us a different equation, so 5x squared minus kx plus 3y squared plus 2ky. I'm going to move the negative 1 over to the other side to become positive 1. Okay, so here we've got to complete the square for both x and y. So I'll start off with x, factor out the 5. Well, I guess let's do it in multiple steps. Okay, so x squared minus k over 5x. And then here we'll factor out the 3. So that's going to give us y squared plus 2k over 3y equals 1. Okay, so now I'll complete the square on the insides here. So that'll give us half of k over 5 is k over 10. So x minus k over 10 squared is going to produce an extra k squared over 100. So I'll subtract the k squared over 10 squared there. So now I'll complete the square here. So I've got y plus half of this would just be k over 3. Woo! Excuse me. And then I'll square this, so that's k squared over 9. So I'll subtract out the k squared over 3 squared. And the 1's still there. And now let's multiply everything back in. So I distribute the 5. So that'll give us 5 times x minus k over 10 squared. And then 5 here cancels out. Well, I guess let's just do it this way. Excuse me. So then one of these 10s is a 5 times 2, and the other 10 is just 10, so the 5 divides the 5. And we'll simplify the rest of this in a minute. So now I'm going to distribute the 3, so that gives me 3y plus k over 3 squared. Let's distribute the 3 here. So now this 3 is just going to divide one of these 3 here. So that's k squared over 3 equals 1. And then we're going to move all the constants. So these things are constants and those things are constants. So the final answer here is going to be 5x minus k over 10 squared plus 3 times y plus k over 3 squared equals 1 plus this thing, k squared over 3, plus this thing, which is going to be k squared over 20. And if we had reason to, we could try and combine all of these under one denominator. I don't feel a strong reason to do that, so that seems good. Okay, let's do problem 2. So for each of these equations, we're supposed to decide what kind of curve is it and put it in a more conventional form. So here I've got x squared plus 3y squared minus 12y plus 9 equals 0. So I know it can't be a parabola because we've got an x squared and a y squared. And a parabola is either going to look like y equals something in terms of x squared, or if it's a kind of a sideways parabola, x in terms of some kind of y squared. So I know it's not a parabola. If it was going to be a circle, it should have the same scale factor on x and y, because a circle is kind of perfectly symmetric. So if I've scaled the y-axis, but I haven't scaled the x-axis, that's going to take the thing that was a circle and it's going to make it an ellipse. So I believe that this should be an ellipse. So let's complete the square here to put it in a more conventional form for an ellipse, sort of a semi-conventional form, because I haven't showed you the perfectly conventional form yet. So y squared minus 12y, minus 4y, and then we'll put negative 9 over here. Oh, this makes me suspicious that maybe, in fact, this is no curve at all. Let's finish doing it, and you'll see why. Maybe you see why already. Okay, so let's do y minus 2 squared, and then we have to subtract an extra 4. Great, that makes sense. Okay, so what do we have here? So we've got x squared and then plus 3y minus 2 squared. Oh, it's going to work out after all. All right, what a trick. So then I'm going to multiply 3 to negative 4, so that gives us negative 12. I'm going to add that negative 12 over here. So that gives me 12 minus 9 is 3. So at first it seemed as if this is the place where like the radius of the untransformed circle would be. And you can have a negative radius, or rather you can, but it means that there would be no coordinates that make this equation true. But as we completed the square here, it introduced this extra constant, which has fixed that problem. So I believe that should be our ellipse. Let's do B. 3x squared plus 9x minus 6y plus 3y squared equals 5. So here I'm seeing the same scale factor for x squared and y squared. And you might wonder, like, it's not the same coefficient on the x and the y's. Like, does that make any difference? But I'm going to guess that this is a circle based on the x squared and the y squared terms. So let's try and complete the square and kind of see what it looks like here. So this is x squared plus 3x. And I'm going to reorder those two terms and factor out the 3. So I'll have 3 times y squared minus 2y equals 5. So now completing the square on the inside, we will have x plus 3 halves. And then I'll subtract out the 9 fourths. And then here I've got 3 times y minus 1 squared. Does that make sense? Yeah. And so then I'll subtract the extra 1 that I'll get. So now multiplying back in, I've got 3x plus 3 halves squared. Multiply the 3 in. So that's going to give me 9 times 3 is 27 fourths. 3y minus 1 squared minus 3 equals 5. And so now let's move this thing and this thing over to the other side because they're constants. Oops. So that gives me 3x plus 3 halves squared plus 3 times y minus 1 squared equals 5 plus 3 is 8 plus 27 over 4. And I don't feel much like combining those. So where have we ended up here? Is this really a circle? It seems like yes, because, I mean, if I wanted to, I could divide through by 3 on all the sides. So let's do that, actually. So let's do 3 halves squared, y minus 1 squared equals 1/3 times 8 plus 27 over 4. So now it's definitely in a more conventional form where you can see it's just a translated x and translated y from the original x squared y squared. And then this is, you know, an expression that just gives a number, and this would be the radius squared. So yes, definitely circle. All right, what about the last one? So this is 2c is 3x squared plus 8x plus 5y minus 2 equals 0. So here I'm noticing I don't have a y squared, so I could move all the x's to this side and I'd have like 5y equals some stuff in terms of x's and x squareds. So that has the form of a conventional parabola. So let's solve for y. Make it look like that. So 5y equals, I'll add 2 on both sides. I will subtract 3x squared on both sides. I'll subtract 8x on both sides. I could just divide by 5 here, but that's not going to put it in a nice form. I think vertex form is going to be a nice form. So let's complete the square here. So I'll move the 2 to the outside. I'll think about these here, and I'll factor out the -3. So that gives me -3 times x squared, and then -8 divided by -3 is 8/3. And let's just make sure that makes sense. You can multiply this back in, so -3 times x squared works. -3 times 8/3, the 3 and the 3 divide, giving me just -8. So that is just a nice sense check to make sure that we're still good. So I got 5y is -3, and then here we've got x plus half of this would be 4/3 squared, and then I have to subtract out the 4 squared over 3 squared. And now we'll multiply it back in. So -3x plus 4/3 squared. Multiply the -3 back in, so negative and negative becomes positive. 3 and 3 divide, so that gives me 16/3 plus 2. And now I can divide everything by 5. So now I have -3/5 x plus 4/3 squared plus 16 over 15, because I divided by 5, plus 2 over 5. And I could combine those if I wanted to. Parabola. All right, let's do 3. So practice interpreting the meaning of parts of an equation. Oops, it got dark in here. Okay, so the equation is the ellipse 3x minus 3 squared plus 4y minus 1 squared equals 64. So where is the center of the ellipse? If I take away all of the scale factors, I would just have the circle x squared plus y squared, except that the circle has been shifted in x and shifted in y. So if you think about here, we're performing the shift before squaring. So this is the same as shifting right by 3 and up by 1. So I believe that the ellipse should be centered at 3, 1 here. So part B, so that was part A, centered at 3, 1. Part B says, okay, so I'm going to plug in x equals 3 and solve for y. What values do I get? So let's do that. If I plug in x equals 3, this becomes 0, so this entire term is 0. So I'll have 4 times y minus 1 squared equals 64. So divide by 4, that gives me y minus 1 squared is 16. I'll take the square root, so y minus 1 is plus or minus 4, and then I'll add 1. So that means 1 plus or minus 4, which let's actually do that. So 1 minus 4 would be -3, and then 1 plus 4 is 5. So let's interpret that now. So what happened? I started by plugging in x equals 3, and you'll notice that that's the exact x-coordinate of the center of the ellipse, and I end up getting y values of -3 here, and 1, 2, 3, 4, 5 up here. So I think that must be the bottom and the top of the ellipse, because if you imagine the shape of an ellipse, and I'm not saying ours looks like this, I'm just drawing any old ellipse. If this is the center, the y-coordinates at the center give you the highest and the lowest y values on the entire ellipse. And so I think that's what must be happening here. And if we were interested in drawing the whole ellipse, we could figure out what's this axis here, and that's actually what part C is asking us to do, almost. Oh no, it's asking me for the total height of the ellipse. Okay, so we've already basically calculated the entire height of the ellipse. It's just the difference between 5 and -3, so it's got a height of 8. But let's do a bonus part D here. The bonus part D is let's figure out where the leftmost and rightmost points are. So if I plug in a y value of 1, that would be plugging in y equals 1 here, and I can solve for the two x values that happen when y is 1. So let's do that. So here I've got 3x minus 3 squared equals 64. So now so this is going to work out a little less cleanly. So x minus 3 squared is 64 thirds. Now I'll take the square root of both sides. So x minus 3 equals root 64, which is, well, let's do the plus or minus 8 over root 3. And now let's add 3. So x is 3 plus or minus 8 over root 3. And hopefully this makes sense. Look at what 3 plus or minus this thing could mean. 3 is the x-coordinate of the center. So 3 plus this number is going to take us a certain distance this way. 3 minus this number is going to take us a certain distance this way. So each of these distances must be 8 over root 3. And that's going to give us our ellipse. I have just drawn an arbitrary distance here, and I made it look like this hits the y-axis here, which it most certainly does not. Let's just like approximate what is what is 8 over root 3. Okay, so 8 over root 3 is, about 4.5. So actually, this point ends up a little bit in the negatives here, and this point would end the same distance this way. So it would be more like that. All right, let's do problem 4. So we've got a point P at 0, negative 4. So let's draw that. So that's P. And we've got a line at negative 2, horizontal line at y equals negative 2. And let's have D1 be the distance between a point x, y to the line P. Sorry, here my problem is written poorly. Give me a second. Okay, I'm back. So D1 is the distance to point P, D2 is the distance to the line. So let's put an arbitrary point here. So this will be xy. D1 is distance to the point. D2 is the straight line distance to the line, as we discussed in class. So let's derive the equation where D1 over D2, so the ratio of D1 to D2 is 1. If I multiply by D2 on both sides, that's just the same as saying the distances are equal, because that's what a ratio of 1 means. Okay, so let's go ahead and write expressions for D1 and D2, as we have done numerous times now. So difference in x's, well, it's silly to say x minus 0 squared, so let's just do x squared here. Here we can say y minus opposite 4. So that gives us y plus 4 squared. And then on this side, d2. All right, so let's think about this. So y is this negative distance that way. But I want to know this distance here. And this distance is always 2. So you might think that it was y minus 2, because this distance between my fingers feels like it should be y. And then if I subtract 2, that gives me the remaining bit. The problem is y is a negative coordinate, so this distance isn't actually y. Because imagine that y is like negative 3, for example, which it would have to be because we are below the x-axis here. So if y were negative 3, I wouldn't say that this distance was negative 3. I would say that distance was 3, the opposite of y. So there's a lot of different ways that you could think about this, but one way to think about it is, so let's take this actual distance first, which is opposite y, and then from opposite y, let's subtract 2, and that gives us what we want. Okay, let's solve. So, or not solve, but let's restructure to put it in a nicer form. So I'll square both sides. And so now this is negative y minus 2 squared. You know what's going to be nicer here, though? Let's factor out the -1 first. So I'll have opposite y plus 2. And now if I square opposite y plus 2, that just becomes y plus 2 squared. I just think that's going to work out more nicely. So let's move all the y things to one side and the x things to the other side. So I'll have y plus 4 squared minus y plus 2 squared. And then I'll move the x squared to this side. And now you could do difference of squareds here, but I'm in the practice of expanding it, so let's expand it instead. So y squared plus 8y plus 16. I'm going to subtract this entire expansion, which is y squared plus 4y plus 4. And now let's see what eliminates. So I got y squared minus y squared, so those go away. I've got 8y minus 4y, gives me 4y, okay? I've got 16 minus 4, which is 12. So now I can move the 12, and I can divide by 4. So that gives me y equals negative x squared minus 12, and then I'll divide everything by 4. So 1/4 of that stuff, and then let's move the negative out. So that'll be negative 1/4 x squared minus 12. Or if you wanted to put it in root form, it could be negative 1/4 x plus root 12 times x minus root 12, because you could use difference of squares, and now you know where the roots are. All right, let's do 4b. So same setup, where I've got y equals -2, and I've got p is at 0, -4, and I'll have an arbitrary point xy. And I've got distance 1 and distance 2, but this time the ratio of distance 1 to distance 2 is 0.5, which is the same thing as 1/2. So I'm going to multiply by d2 and multiply by 2, so that gives me 2 distance 1 equals distance 2. And now we can just do the same derivation we always do. So let's, oh, right. Okay, so x squared, and then this is y minus opposite 4, so y plus 4 squared. And then d2, we had this discussion last time, so this should be negative y minus 2. But I'm going to rewrite this actually as opposite y plus 2. Now I'll square both sides, so 2 squares to be 4, and then I'm going to distribute it in here to the x squared and to the y plus 4 squared. And then this, when I square it, becomes y plus 2 squared. Okay, so let's do the same thing. I'm going to keep the x squared on this side, but I'm going to move the y squared over. So this will be, I guess I'll start expanding as well. So y squared plus 8y plus 16. And then I'm going to be subtracting, because I'm going to move that to this side, but I'm going to expand it. Y squared plus 4y plus 4 equals 0. Okay, let's distribute this in now. So 4y squared plus 32y plus 16 times 4. You could multiply out, but let's keep it in a slightly factored form for the moment, because it just might make it easier to cancel things later. And then I guess let's distribute the negative. So y squared minus 4y minus 4 equals 0. And then let's not forget the 4x squared over here. Okay, so 4y squared minus y squared gives us 3y squared. So 32 minus 4 gives us 28y. Okay. So now 16 times 4 minus 4. All right, well, I guess we really do have to think about this. So 16 times 4, let's break this into chunks. So 4 times the 10 here gives us 40. 4 times the 6 gives us 24. 40 plus 24 gives us 64. So I think this should be 64 minus 4 gives us 60 equals 0. Cool. Let's complete the square here. Let's factor out the 3. So y squared plus 28 thirds y. Let's keep the 60 on the outside. So now, completing the square on the inside, we've got y plus half of this, so that would be 14 thirds squared. And then we have to subtract 14 squared over 3 squared. And the 60 is still here. Okay, so let's distribute the 3 back in. So now we've got 4x squared plus 3 times y plus 14 thirds squared. Let's multiply the 3 in. So that's minus 14 squared just divided by 3 now, plus 60 equals 0. So now let's move all of this to the other side. So we've got 4x squared plus 3 plus 14 thirds, y plus 14 thirds squared equals 14 squared over 3 minus 60. And I can see this is a positive, whoops, excuse me. I can see this is a positive number because 14 squared over 3 just seems like it's going to be larger than 60. And it's my number sense tells me that. Cool. Wait, so what do we have here? We've got an ellipse because we've got an x squared plus a y squared, but they're being scaled by different amounts in the 2 dimensions, so it's no longer a circle.